All right, Cassidy. So here's kind of what's going on. I made some data. Don't worry about this undefined thing. I tried to erase something, I wouldn't do it. Um, but you could look at number in your group size, and the smallest you would have is 2, and I just went up to 9. Actually, I didn't do any more than that. This isn't, actually what you're working with specifically, but it's the idea. And so your data looks something like this, and so you can fit a straight line to it. So if these are your group sizes, and over here in the y part are your probabilities, then you see you have curved data like this. If you were to look at your data, they're going to be kind of curved like this, and you can see that. And you can fit a straight line to that. Now, when you look at our textbook and so forth, it would say, this isn't the best straight line, because if you looked at the residuals, or these differences, the vertical differences, you'd see a pattern, right? These dots are below at each end, and in the middle they're high, and you don't want to see a pattern like that. You want to see randomness, and this is a definite pattern, and so a straight line's not the best, and so that's one thing. But another major reason why a straight line's not the best is just look at what happens up here. Remember, you're predicting probabilities. Probabilities are between 0 and 1, or 0 and 100%. You can't have more than a sure thing. And so notice what this straight line did, though, is if I'm here at 9, even with the right data, it predicts a value of 1.1. That's not good. And so even though you can use a linear regression on these data without transforming them, you really should transform them. And what that transformation is doing is allowing you actually to fit something like this thing down here, which is what the actual data are. Because remember, what that transformation does is it takes your y values, that's the f of x, it takes your y values, subtracts them from 1. Well, you see, if I write something like that out, it's probably not going to like what I do. Well, I don't know, it may be happy with what I do, but I'm not trying to do that. So what you have is, you have y is equal to 1 minus stuff. Okay, so it doesn't know what to make of that. But if you subtract y from both sides and add stuff to both sides, you get stuff is equal to 1 minus y. And that's the beginning of your transformation. And so all we did was really sort of switch sides with this f of x, which is our y, and this funky looking exponential expression. And then we take the log of both sides, and the thing is when you take the natural log of e to something, so if I take the natural log of e to something, okay, what I get is that equals something. And so you've got this e to all this stuff up here equals 1 minus your y values. That's the stuff right here. All of that is equal to 1 minus your y values. Now if I take the natural log of both sides, it gets rid of the e basically. It just gets at the exponent. And so what we end up with is that my minus x squared minus x, all of that divided by 20 is equal to the natural log of the 1 minus y. And look at that, it just plotted that as blue, and wow, I didn't even think about it doing that, but yeah, right? It does exactly that. And you see your transform data are this side, that's your response, and here the minus x squared minus x over 20, well, that's just really, you could think of it as minus 1 over 20 x squared, and then minus 1 over 20x as the coefficients. But this is what the multiple regression is allowing you to do. It's allowing you to use both x and x squared instead of just x. And you're doing it with this transform situation, and so when it doesn't look like a straight line here, right? But if you were to plot those data, and I could actually do that up here, I suppose, if I, no, yeah, there we go. I think if I do the natural log of 1 minus f of x1, like that. See, it's still undefined, and I get these negative numbers, but so I took that transformation, that natural log of 1 minus this thing. So I did that. Here's my raw data that we're doing that. Now I transform that data, and I should be able to find it down here, and look at that. There's the data, and if I plot y equals, and then this stuff, let's see if I can just copy and paste it. Oops, not like that, I can't. Control C and Control V. Look at that. See, this goes right through that transformed data. So you see, by using your transformed y values, you are able to find this complicated non-straight relationship up here, because in essence you've changed it to these, okay, but it's all related. And it's a bit much to see, but it's all related. That you see this relationship here, the blue one, actually for values of x and y is exactly the same as this relationship here, the red one, in terms of the untransformed stuff. And so I kind of misspoke on that, but let's go back a little bit. This transformed relationship in blue is exactly that relationship that you're hoping to get, which is much better than that straight line. So this is the same thing, but here, if I rename that as just y, and I try to do this, well, multiple regression allows me to get this answer. Okay, I can get that answer. But see, once I have that answer, I can just put that thing, whatever it is, up here and get the real answer. And that's what you're going for. You are working on your transform data to get this answer, but then once you have that, your real live formula is this one, where you just take that piece and you put it in the exponent of the number e. Okay, so that's quite a bit, but that's why you want to work with your transform data as your response, and not the original data. Now I have a couple of your things here, so let me pull up your first one. I'll put it on edit. Now this is not a big deal to fix this up. So I looked at this and I noticed that it said N here, which is the probability of match. It should have been M, the natural log of the matches. And so to change that though, all you have to do is go in, highlight, make sure you highlight everything and no more than what's there. So I highlight it all, and you'll have to do this on each page, but now that I highlighted it, I'll go in here and I'll edit it. Again, notice it's staying highlighted. I'll just backspace and do an M. Well, maybe I will. I did change that to where I can edit. Well, that is okay. Let me see now if I can do it. Okay, for some reason it's not letting me change it, but I've got your file. I haven't saved it. Oh, I see. Okay, it says up here read only. So let me first just Control Shift Enter to get out of there, and I'm gonna do this real quick. I'm just gonna save this as this file. I guess where's my desktop? To my desktop. So I'll say save, and I'll keep your format. Okay, so there I've saved it, and now I'm gonna go in here and let's try. Yeah, see, now it's letting me. It was just now I've got everything highlighted, so I think this will work. So I changed those N's to M's, and I do my Control Shift Enter, and everything changes just like that. And if you look at any of these in there, they all say M. And so I do that, and then I go to the next one, and it's still M. In that case, you just want to look and see what it is. So I highlight everything all the way down to the NAs, and again, oops, I just make that an M, make that an M. Notice everything's highlighted. Control Shift Enter, and there it fixed that up. Now I think I'm really sure that when you do that on this one, on this first one, the 94 through 2003, you are going to get the same columns exactly that you have. It's just kind of weird that way, but I think you're going to get exactly those same columns: 1997, group size squares, group size, and the intercept. So well, the intercept's not a column, but you're going to get three columns plus the intercept. I believe what you'll find on your other data, these data, that at some point, maybe right near the beginning, you'll see that the intercept, I think you'll see this, that the intercept should be 0. It will actually have a p-value that's really big. Now the way you take care of that is, let me highlight everything and click on that. Well, it doesn't look a lot bigger. Let me see if I can make it bigger here. Yeah. So looking at your, where'd it go? Let me click on it again. I don't know why it disappeared. Let me just do a Control Shift Enter, and then click on that again. Okay, so here, remember that 1 is for having a y-intercept. If you put it at 0, it will set the y-intercept at 0. And so you can do that and change this thing so it forces the y-intercept to be 0. And I think you're going to have to do that in this set of data. Okay, so hopefully this video helps. It's probably getting kind of long now, but I will download it or upload it actually to YouTube.